Okay, so you should have been able to take the square, the figure, right? And we want to say where that blue square is. So here's what I want you to do. So you're going to go into the assignment, which is right here. All right, and then again, yours is going to look a little different. So you're going to submit, put in, this is where I think or describe what the new shape or the next shape is going to look like. All right. Then if you submit that, it will say you have one submission left. So what that basically does is save it. So I set the assignment up so you can have two submissions. So there's the first one, and then the next one would be for you to go through and do the rest of the work that we're going to have you do. All right. Now, if it happens that you so you're working on an assignment and then you submit it, but you weren't done because something came up and it's still not due yet, you need to let me know, because we have to figure out another way for you to get the answers to me. Okay, because once you submit that, that's it. All right, so we have to come up with another way. But just email me and we'll work through it. All right, I want to get back to this. So one of the things that we want to think about is what made you decide upon your answer. Right? So whatever it was that you decided to draw or describe, what made you think that? Because that's important. And one of the things that when we look at this, we're talking about these patterns, right? There's a certain type of reasoning that goes along with these patterns, right? And one of that is called inductive reasoning. Now, I'm not going to hold you responsible for any of this here on inductive reasoning. So if you're writing things down, you can, but you don't have to worry too much about it. I'm not going to ask you what it is. Right? But inductive reasoning is reasoning from patterns. So we're looking at patterns, all right, to come up with our reasoning on this. And inductive reasoning is something that you use a lot just in a real life situation. And you have been for years and years and years, because you get conditioned to certain things. So you know that if you do if you eat a lot of maybe spicy food or something like that, it might make you sick, right? So you kind of know that it's a conditioned behavior. So my pattern is, hey, if I eat 20 tacos that are really spicy, and chances are I might not be feeling too good. So it is a pattern, a behavior that happens. All right, and that's inductive reasoning. So we're going to use inductive reasoning to come up with some throughout the whole class, looking at different patterns that we see. What do we notice, okay, from the things that we're testing, and then we can come up with a reasoning for that. And we call that a conjecture. Okay, so a conjecture is a written or verbal observation from a pattern. Okay, so if we see something occurring, then we will conjecture, this is what I think. All right, so when you did the next figure, you made a conjecture. You said, this is what I think. All right, because you noticed a pattern and you drew it out. So you can either write them or you can verbalize them, but that's a conjecture. All right. So what I want to do now is talk a little bit about some number patterns. All right, so let's do this real quick here. So let's start out with some number patterns here. We want to get the next three. So we're looking for a pattern. Now, these numbers obviously are very, very familiar to you, right? You should know what the next three are. Right, but what's more important is where did those come from? Well, we know that they're even numbers, obviously, but if we look here, we see that the difference between each one is 2. So it has a constant difference, we say in mathematics. So then that gives us our pattern, and there's our conjecture. Sweet so far, right? Actually, I don't think well, let's go ahead and do this one. All right. Now, this is kind of a tricky one because if I look at these differences, right, I notice that they're not constant, right? They're changing. But I also notice this. These numbers are the same as these numbers. So what does that mean? Well, that means that this, right, difference here should be 10, and then 12, and then 14, which helps me go back and get these numbers. All right, so number patterns helps you to look at the differences. All right, here's a situation, 3, 9, 27, 81. I could look at the differences, right? Because that's what we were just talking about. Yeah, that's right. So I think I screwed this one up. Hang on. Where's my eraser here? No, that one's right. I got it right. Okay, so back to the differences here. 6, 18, 54. Now, those numbers I don't recognize them at all, right? So looking at the differences, it isn't helping me on this one. But some of you probably already figured it out. Because if we look at these numbers, we see that 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So I can do this one and get this. I can do this one and get this. And now I kind of need a calculator to figure out the next one. Because 729 times 3, I'm not so sure I know that one. So some patterns are going to be where they're going to be multiplied, and you have to see that. Okay, these are all number patterns. Sweet stuff. Let's do one more. Oh no, I want to do this one. Hang on. Oh, I just need to do this. Okay. This is the one I want to do. Let's see. 16, 25. All right, I'm going to put a 1 in front. All right. So in these numbers, again, let's look at the differences, right? So 1, 2, 5, 7, 9. All right, so I don't know if I see a pattern there, right? Because it just looks a little different. Well, let's see. Let's go differences one more time. 1, 3, 2. Something happened here. I guess that's right. 2. This is difference 2. Yeah. Okay. So man, I just don't see anything there, right? So I'm thinking, well, something's not right. I'm gonna have to look for something else. These numbers we call squares, okay? Because 1 squared is 1, Oh, 2 is not supposed to be in there. I knew I had something wrong. Dang it. So it'd be 3, 5, 7, 9. There we go. So the difference, second set of difference is 2, 2, 2, and 2. So now we know what this difference has got to be, right? So that'd be 11, 13, 15. So now I can go back and say, oh, this is going to be 36, this is going to be 49, and this is going to be 64. But like I was saying, these are squares. So 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and 8 squared. We call these perfect squares or just squares. All right. So you're going to see those. That pattern is going to show up a lot. All right. So those are going to be your squares. So those are some number patterns. All right. Look for those differences to help you. If you can't see anything in the differences, then maybe it's being multiplied by something each time. All right. Those are your differences. I think that's it. So what we're going to have you do now is go ahead and we're going to do some more things with these number patterns. We'll have an assignment. I'll probably see you on, let's see, Monday, I think. Yeah, Monday. So click into the Zoom session. Be ready to go Monday morning, 8:05. We'll charge into some more number patterns and pattern things. I'm going to give you some stuff to work on, and then we might do some more stuff. All right. Have a great weekend.